Our new distinguished speaker, Mr. Shravan Yadav, a principal engineer, data enthusiast, and automation expert. With an impressive 13 years of extensive experience, Mr. Yadav has excelled in Python, PLSQL, Tableau, QuickSight, shell scripting, and AWS. He has led teams of developers, taken charge of project and resource growth, and has been recognized for his remarkable contributions to automating manual tasks, saving countless hours of efforts. His wealth of knowledge and hands on expertise promises to provide us with invaluable insights. Let's warmly welcome Mr. Shravan Yadav to enlighten us with his session. Sir, please.
Hello, Shravan, sir.
Okay, dear participants, wait for some time. We will join shortly.
Am I audible now?
Yes, sir.
Yes, sir. Now you are audible.
Yeah, thanks for having me.
Yes, sir.
My name is Shravan Kumar Yadav, and I am working as a principal in data development. And total I have 13 years of experience. I'm based out in Noida only, and I'm basically from Varanasi. So today I would be covering the section on history and evolution of is Generative. So is my screen visible?
Not yet, sir.
Now, anytime. Okay, is it visible now?
Yes, now it is visible.
Yes, sir.
Okay. So I'm switching off my camera. Okay. So just wanted to take this session and wanted to convey the message like why and how we have evolved in generative AI and what was the history behind it and what was the experimentation and research has been done behind generative AI or whatever we are doing. So the flow of the PPT will be like I will be covering the early beginnings of AI, like how the AI has been started, was the concept, what was the seed which we grew till the generative AI. Then I move forward to machine translation, skipping the many machine learning models, especially because I want to cover like how and what laid the foundation for generative AI, not for AI. So machine translation, I can say, is a key thing that happened where we wanted to tell something to machine and machine understands it and then delivers the uh, relevant output to us. So that's why I want to cover the machine translation. Then I want to cover like uh, moving in machine translation, how we laid the foundation for generative AI in 20 in this millennium. Then how different deep learning models are transforming towards the generative AI, and then the generative AI breakthrough. That's what we have. So after covering all those, I will cover the future directions and ethical consideration on generative AI. So like whatever we are today and like from where we are, what is the future we are focusing on targeting for, and how generative AI will evolve in that and fit into that futuristic view. So moving forward, so is my PPT visible or this black box is also visible to you? Hello?
Yeah.
Okay. So is my voice fine now?
Your voice is a little bit low, sir. It is possible.
Yeah, is it fine now?
Yeah, now it is fine.
Okay. Okay. Maybe the earphone got that. Yeah. So starting on the early beginning of AI, basically, not Gen AI. So everyone knows the subject, the automata, the book we have, the story of automata, and everyone watched the imitation game that features the Alan Turing test in that. So that was the first machine built which was predicting the sequence of letters or decoding, basically encrypting and decrypting the codes that were used during World War II. So that that was also built to solve a problem, like when Germans were communicating through encoded messages. So Germans were communicating through encoded messages. So people were focused on decrypting those messages so that they can uh, know their plans and take the actions accordingly with their armies and navies. So that was the laying brick in uh, in AI field. So that was the first thing that we have learned. Like in my college days, also I have learned about how we are creating the sequence, generating the sequence by a machine, how the sequence is generated, how the compilers or the uh, of different languages were built. So that was the first breakthrough that we had via Alan Turing that laid the foundation for this. After that, in 1958, there came the concept of perceptron. So, what is perceptron? Basically, in our human brain, the brain cells are called neurons, and neurons have some dendrites which uh, receive the input from another neuron, and then they transfer the output to another neuron. So that from there came the concept of perceptron, where they are trying to mimic the functionality that we have in the human brain through neurons. So Roosevelt, Rosenfeld uh, came through perceptron, and that laid the foundation for neural networks. So now neural networks came that changed the whole world, that you can train and you can give a specific input to the machine, and it will generate the output which is close to the human prediction. So that's why perceptron is the key element in neural network, and it has changed every bit after that. In 1960s and 1970s also, there came a symbolic AI. So what is symbolic AI? Like it is expert system which is designed to do, like I want to do heart surgery. So machine is trained with all the known whatever knowledge is known to human is fed into that machine, so that machine can perform the heart surgery or solve like in a heart surgery also, like they want to do a specific to solve a specific problem, so it will do that only. So that expert system was built in 1960s and 1970s. So these were the early beginnings of AI. So this laid the foundation that some like we can predict something from machines, like whatever inputs and outputs we are giving to machines, they can do something, or they can do 90% similar to human predictions, or they can sometimes outperform humans also in some cases if specific inputs are provided. So these are now why I'm focusing that it is only giving input and output. It is not generating by itself. If some input is given to a machine and output is generated, and then output is close to the human prediction. So that was happening in early beginning. Going to the next slide. So machine translation. As I am more focusing on machine translation. Why? Because this is the point where machine started to understand what we are giving input to them. So it's not something like we are giving input and to generate the output, to predict the output. No, it is like whatever we are giving the input, the machine is able to understand, join the connection between sentences, and join and create the output on the basis of that. So here, like from human input, they understand the human input and they connect, build the logic, which is similar to like how human builds the logic, and then they generate the output or machine human prediction. So I am focusing on machine translation, that they are like translating your input into something that you require. Like it may be English to Hindi, maybe English to like some feedback you are giving, then rating the feedback positive, negative, or it is a paragraph and then summarizing the paragraph in smaller sentences. So it is the machine translation. It is not a direct output they are generating. They are translating your input into something different from what you want, what is your desired output for. So the first lead foundation was done by US in ALPAC committee, where translation was done, and it was basically rule-based translation. Okay, if it is this, then do this, like if else condition, and it is very extensive. Like you have to build a lot of rules, and like at that time, like to write those rules on a hard disk, it would take a lot of memory. So the hard disk space and the processing power was not so much advanced at that time. So it was taking too much time to translate or do the translation of the text and then maintain it. So that is so various in machine translation also. When they have started doing the translation, there are various types of translation as well. So I have talked about rule-based translation, that it's called RBMT. So it is completely based on rules. So first they have started the translation for languages, like they want to decode some Russian language into English or English language into Russian language. So they started like, okay, if I give you an example, like in Hindi we have like मैं पानी पीता हूँ. So in English it is like मैं for I water drink. So like मैं पानी पीता हूँ is I water drink. So if it is translated like that, like one-to-one mapping, like one word is translated into English without any tenses in it. I water drink. So in English it does not make sense, but like people in army or navy, they can make a sense out of it, like what is the decoded message they want to convey, and then they can extract the whole messages and work on it. So it is completely based on language. And the two examples of this RBMT systems are prompt and syspen at that time. So those were the RBMT models at that time. So in RBMT also we have different types of translation. So if I talk about RBMT only, it has direct machine translation, transfer-based RBMT, interlingual machine translation. So direct machine translation is the basic translation that I have mentioned. Transfer-based RBMT is like they have some, they have started countering the sequence of words also. Like they convert the Hindi to English one-to-one translation, but they also try to see like how the context will work, how the sequence will work. Okay, so I water drink does not make sense, so it should be I drink water in English. So they wanted to make a meaningful sentence, not just direct translation in transfer-based RBMT. But there was a drawback in transfer-based RBMT still, that it was not able to translate the tenses of these. Like, मैं पानी पीता था is still like I drink water. I drank water not. So it was lagging there. So transfer-based has that drawback. So they came up with interlingual machine translation. So there they have made a rule. Let's transfer all the translation into an intermediate language, and from intermediate language to we will convert it into final translation of a final language. So like they are converting the like I want to convert Hindi into French, so they will first convert the Hindi into English and then English into French. So there will be always a intermediate language. It will be converted first, and then all the target languages are converted from the from the intermediate language. Then after RBMT, we have example-based machine learning, machine translation, or you can say dictionary-based machine translation. So they have started maintaining a dictionary for all the words, and then do the translation. Like they cover the tenses also, and they have started storing the phrases also. Like if they want to convert the idiom basically in some other language, so they have stored the whole idiom and their translation into other language, so that if they encounter any language barrier there, they translate the whole basically phrases only. So like I went to Agra and then I went to Delhi. So I went to phrase is common in the translation is required for I went to first time. For other times it will use the same translation, that is. And then for Agra and Delhi, I will search like what is the translation for Agra and Delhi for the rest of the phrases were getting stored to do the translation. After that, we have the statistical machine translation (SMT), where we are doing the NLP, the bag of words, the syntax-based, named entity relationship, and phrase-based SMT. So the examples of SMT were like the bag of words, like the term frequency or inverse term frequency we were calculating. So like in SMT, we have started looking like in a phrase. Let's suppose uh, money and some amount is coming 10 times. So we will categorize this as a spam mail from there. So like it calculates the or predicts the next word on the basis of frequency of those words coming in the sentence or coming in the phrases. So that's how like machine learning has evolved. Bag of words is there, then TF, IDF is there, then named entity relationships are there. They are also using the syntax-based machine translation. So they want to know the relation between the words, when to use where, when to use are. So that's how we reach to statistical machine translation. After that, we know that the neural machine translation comes like with the introduction of neural networks. Basically, it has started using RNN, LSTM, the recurrent neural network, and long short-term memory neural network. So neural network, we know is a in neural network we have different layers, and each layer is connected with each other through a mesh of network. So that's why it is called network. And neural, why we are saying it neural, because it is mimicking the human brain. Like neurons are interconnected with each other through a network. In a similar manner, each layer of uh, neural networks are connected to each other through a huge mesh of networks. So that's why they are called neural machine learning. So neural machine translation has done a huge jump in terms of machine translation, where we were able to translate and correctly and able to maintain the context of the sentence without losing that. We are easily converting the Hindi to English, and we are with proper grammar, with proper syntax, and not in a single sentence. Basically, a group of phrases or group of sentences we are able to translate in a minutes of time. So that was a game changer in terms of machine translation, or you can say that also laid the foundation for Gen AI. So after reaching the neural network, people started using like what we can do more to make it more accurate and make it more faster. Because neural network was translating the uh, sentences in a sequential manner. It was taking one word at a time, then looking backward the rest of the words, and then taking another word, and then taking rest of the looking into the rest of the sentence, and then translating it. But so they want to like this is sequential manner. So they want to optimize it, like how we can optimize it more so that it will be faster to translate. Currently, like till 2015, we don't have that machine, but after 2015, we have started seeing like the space is the hard disk is becoming cheaper, and the compute power is getting more costly. So, like in NMT, we have the hard disk to store the data, but the compute power is more because it is converting sequence to sequence translation. So yeah, that I have covered. So just to give overview, like in 1990, only like IBM Research Center has designed the first machine translation system, and like I have given the examples like bag of words and considering the word order in sentences, so they can look into those and correctly predict the next word in the sentence. So the classic example of statistical machine translation is like when you write a Gmail, like it was long back ago only, but when you write a email, now it is using the latest algorithm. But like 10 years back also, when you write a email on Gmail, it will automatically predict the next word. So that was using this bag of words, like on the basis of what you have written so far, what would be the next word that you can write. So that was using bag of words only. So yeah, we were still neural networks or neural machine translation. So as I said, like it was pivotal for the evolution of Gen AI, and what was happening in neural machine translation. So in neural machine translation, we have feed forward thing. Like basically, it is simple thing like when input moves through the neural network and reaches to the output, it is called feed forward. It has weights and biases in the layers in that. So yesterday I will take you through the neural network session, and I will show you the exact picture what is happening within the neural network. So just overview, like feed forward is a process, like to generate the output, how you feed the input to the neural network and generate the output. That is the like happy scenario. Okay, in every machine learning model, you give input and the output is generated. So you don't know the implementation, what is happening, like in linear regression or logistic regression also, like what is happening behind the model, what is the mathematics term. So that is the happy scenario, that is feed forward. But like in 1986, Geoffrey Hinton and Rummel Hart and Ronald Williams introduced the backpropagation algorithm. So what is this backpropagation algorithm? So like when you do a linear regression and you define a error function basically, right? How error function basically, or loss function basically, the prediction done by model versus the actual output. So how much that is deviating, that is called loss function. Okay. So that on the basis of that loss function, backpropagation has been coined, and okay, they said, okay, let's minimize this loss function so that our predicted output from the model will be close to actual output. Okay, that is making sense. So how we can do that in a neural network? Basically, linear regression is a simple line equation, but how we can do in a neural network? So they have coined this backpropagation, like, okay, this output is generated from the model, and this is the actual output. This is the deviation. Now go backward in the neural network and minimize this gap, what you are getting from the predicted output versus actual output. So that is the backpropagation, and it is very helpful in implementing neural network, and it has improved the efficiency of, so that they can generate more human-like output, and it would be like the loss would be, or the gap would be very minimal, or it will be more like human. Like it is more like actual output that you can give it. So, so yeah, in backpropagation also, like there are different layers, and we go backward from output to the input thing. Basically, we don't change the input, but we change the weights and biases of the neural. So that is happening in the background. So it was also a key element in neural network implementation. So after that, like deep learning foundations has been led between 1980s and 1990s. So there was a term, here it is a term written AI winter. So AI winter is basically a cool down period where like researchers or people are not doing enough to are not doing or not innovating enough in AI field. So like there was a cool down period, like okay, everyone said okay, neural network is there, reinforcement learning is there, we are happy, and it is what a model it is, and it is predicting exact what we have built, and like the output is like matching with 0.001 error percentage of error, and everyone was happy with that. But deep learning foundations came and they changed everything. Okay, no, there is more. There is more beyond neural networks, neural machine translation. So the deep learning foundation came and said that there are better techniques and better hardware now, and you can scale your models and scale your data and predict more accurately than a neural network. So that's why it is very important in deep learning foundation. So moving forward, so till here I have told you like how we have reached to neural networks and what is happening. So how it is connected to generative AI? So far, like I have given you like how Alan Turing started building that and like the foundation for AI. Now we have reached to translation, and now machine is able to translate. Machine is able to understand whatever input we are giving to it. Now what after that? So there are after neural, it started laying foundation for generative AI. So how? So there are deep learning algorithms and uh, the extensive versions of deep learning algorithms which are truly generating something. So till neural networks, they are only taking the input and predicting the output and matching the predicted output with the actual output. But now is the time where the machine started generating by itself, by suggesting itself, predicting itself, something new. Like previously, it was like only known factors were given to AI, and it was predicting within the known factor. But now it can predict if some unknown factor also comes in. Okay, so it was that impact. So as I said, so first generative model like Geoffrey Hinton introduced the concept of deep belief network, which could model complex data distribution, laying the groundwork of generative model. So here, deep belief network basically laid the foundation. Like if you provide labeled or unlabeled data, I will consume it, I will understand it, and I will make the connection between data. So it is like learning from the data and building understanding. That has been happening in deep belief network. I have covered this recurrent neural network and LSTM. So recurrent uh, neural networks are networks are yes. So RNN long short term memories are memory neural networks are built for sequential data, and they were able to consume the data and able to generate the data, generate the text, and generate the time series prediction. So, like, uh, I want, let's suppose, like, I have given the input, like, okay, I am writing a story and I was going through a jungle and I got slipped and I got hurt. I stopped there and I want the AI to complete the story. So AI will suggest, like, okay, what happened next in the story. So the AI will complete the story. So that's what's happening in the text generation thing. Then a time series prediction, like I am giving the input till March and then they can predict the number for next financial year. So that has been happening. So why RNNs and LSTM? So there was a drawback in RNNs that, as I explained, the gap between the predicted output and actual output was huge. So there are, to measure that gap, there are different functions. And in the RNNs, when we train the RNN with feed forward and back propagation again and again, so the loss function sometimes increases. And like with each iteration it keeps increasing, so that drawback of like exploding and vanishing gradient, you can say, in RNN has been fixed in LSTM, long short term memory neural net. So that's why these two are uh, mentioned together, because RNN's drawbacks are fixed in LSTM and they have been made more powerful than RNN. So coming to the next, like uh, GAN, basically generative adversarial network. So as Rosa also explained, like generative adversarial networks were consist of two neural networks, basically generator and a discriminator, and they were like creating high definition images from the text. So like they can edit. Uh, they can edit. They can like they can create the broken images. Like if an image is incomplete, so if you can give the input to the like in some case eyes are missing and you want AI to construct the eyes, so the AI would create the eyes on the images, and they can also do the uh, style transfer. So what is style transfer? So style transfer is like you are providing your image and it will be converted into animated kind of image. Like they can cartoonize the images or modify the images. So that kind of uh, uh, conversion has been done. So why we are mentioning that? Like till here, till RNNs and LSTMs, we were only doing the text and generating the text. But now, after introduction of GAN, now you can work on images also. Like you can complete the broken images, you can modify the images. So till now we were only talking about translations and text. Now with Gen AI, we stepped into tools of images also. So now you can work on images, you can create images from scratch and work on. So, so far we have said like what laid the foundation of Gen AI. So I said like RNs, LSTM, and deep belief networks and GAN. So like text prediction to image prediction. So here we are covering like what transformation has been done in deep learning, so that we are creating Gen AI and LLM and different models which are publicly available. So here, like or uh, two or three things basically happen transformatively in a deep learning model. First is the sequence to sequence, second the attention mechanism, and third is the transformer model. So as I said, like sequence to sequence model are like introduced by Google only, and and it is, as I mentioned earlier, like it is consuming the data sequentially. It is not like when you give input a sentence, it would pick one word at a time, and it would then consume it. Then it would pick another word and then consume it in the model, and then convert uh, into final output, into machine translation or something. Suppose like you have a paragraph and you want to summarize it, or you want to translate it into from Hindi to English, or if it is in English only and it is like 5-page paragraph you want to summarize it, then you can give it as input. So it would pick one word at a time and uh, convert it into the sequence. So don't want to go into the architecture of it, but like it is consists of encoder and decoder. The sequential input is given to encoder, then encoder passes the text to decoder, and then decoder generates some translated uh, sentence or the summarized part of the sentence. So that is happening. So sequence to sequence models are considered RNNs only. Then I have explained like RNNs have drawback. Then they were replaced by LSTM. So now the sequence to sequence model was working better in LSTM. Then we have research paper was published like attention is all you need. So you can Google it and see like attention is all you need. So in that research paper, like it was like summary of that was, see, I don't want to look at the whole paragraph. I only want to look at the keywords within the paragraph to understand the whole paragraph. So that was the summary. So as I mentioned in the PPT, also like labels model focus on specific parts of the input sequences, not the whole sequence. And then it is enhancing the capabilities of sequence to sequence model. So whatever sequence to sequence was built, then the research paper came like attention is all you need. Then they have, okay, we don't want to read the whole sentence each and every word, only the keywords within that, and then work on it. So that made a huge jump basically. So it basically, while reading the each and every word, it the thing like, okay, read only the keywords from the input. Then came the transformer. So what is happening in the transformer? So even we have the keywords, but the sequence to sequence and uh, attention model are reading it sequentially, right? So what happened in transformer, like it completely changed. Like let's read the input in parallel and generate the output in parallel. So while reading the input, like while training the data, it is like the input data is completely fed to encoder and decoder both, and the output is generated faster. So you see like here like the reading of data is optimized. First, like previously it was like first encoder was consuming the whole data, then it was passed to decoder. Now the data is passed to encoder and decoder in parallel manner, and the output is generated faster. So this architecture helps a lot because previously it was taking more time to train the model and then waiting for it to work. But now like it has become faster, and uh, it has fixed major performance. So using the transformer only, Google introduced the bidirectional encoder representation for transformer, the BERT model. So it is a pre-trained language model that that is used in like text generation, text classification, sentiment analysis, and understanding the context bidirectionally. So using like transformer, like still what models we are using like in ChatGPT and uh, others, so they are using the transformer only. So like GPT one I can say like it's the basic decoder model where like they want to a simple chatbot like of thing. So so people can ask a simple question and simple questions were answered by the bot. Excuse me, let me. Okay, so OpenAI changed the game by providing the ChatGPT to all people in the world. So it is completely free. Anyone can log in and try it out and use it in the code also. Basically, they provide the some free API uh, uh, to be used in your code and integrate with your system. So GPT-1 is simple question answering chatbot. Then GPT-2 came where like uh, where the data set was used as compared to GPT. So if you compare different models, here I have noted down like how different attention to GPT-2, GPT-2, GPT-3, LAMDA, Gopher, and Scintilla are used. So if you see attention versus GPT, the pre-trained token in the last row basically is in attention it is 160 million and in GPT it is 125 billion. Okay, this became 10 times when we moved from GPT to GPT-2. And as you can see, the number of parameters are also changing from GPT to GPT-2. Right? In GPT, it was 117 million, and in GPT-2, it is 1.5 billion parameters. So, parameters are basically weights and biases, which are used in the transformers and in the encoders and decoders. In neural networks also, like if we have studied, like there are weights and biases. So those were the parameters. Basically. So that much amount of so as you move to GPT-3, like you can see like 175 billion parameters, and it is around 300 billion retrained total. So as new models are like everyone has some special. So GPT-4 is coming. It is already open, and GPT-4 can understand images, videos, text, to voice messages, and take up your question. Right. So GPT-4 is based on multimodal. We will discuss that in further slides. But yeah, you can see like how the evolution has been happening from a simple attention to GPT-3, then LAMDA, Gopher, and Scintilla. So LAMDA is again you can see nothing major between GPT-3 and LAMDA. But when you move to Gopher and Scintilla, so if you try to build a GPT or GPT-2 or GPT-3 on your local machine, you won't be able to because that much amount of data storage you need and then processing power to train your model on that set of data. So Gopher and Scintilla, what they do, basically they want to optimize this model. Okay, how we can make this faster, like how we can make the compute faster, how can make the storage faster. So Scintilla is a next version of Gopher only. So they wanted to train more on data and also optimize the thing like you can train it quickly or optimize it quickly. So Scintilla is currently available in public, and you can see like you can read the details like how it was trained and why it was built when we already have the GPT for in market. So yeah, am I going too fast or too slow? Let me know. Yeah.
It's okay, sir. You are going in very smooth speed.
Okay. Thank you. So Yeah, so apart from this also, like we have Gemini also from Google, right? Which and Gemini was again like built on a lot of data, and it was trying to build like it will be more like human. Like even on the Android phones also, you can see like whole Google package. With whole Google package, Gemini is also pre-installed now. Like there is no escape from there. So you can have a verbal chat with them like you do with humans. So it was trying to build as close to as human, so that you're not keeping a mobile, you're keeping a emotionful human in your pocket. Right? So yeah, so these were happening. So moving to the next slide. So what was the major breakthrough in terms of field of AI that has been happening? Yeah. So now we have reached, like we have built the Gen. Now it is reading images. Now it is generating output by themselves, not as per our needs. And now they are talking to us. Now what else? Like what breakthroughs have been done? So as I said, like GPT-1 was only chat based, no images, no videos you can share and ask them to read or predict or create. So Delhi came in 2021, right? So it was to enhance the image qualities, like as I said, like broken images or like improve the contrast or improve the sharpness of the images. So you can go there and uh, uh, upload the image, and in text you can provide the input. Okay, please make this pic more colorful. So it will do some magic and from the back end. Uh, Modify your image. So that has been done by Delhi. Then Clip came, the contrastive language image pre-training. So uh, with Clip, like you can give a whole paragraph about the image and explain the image, and then you can ask, okay, create an image from similar to the above provided and create a image on the next paragraph. So it will convert your text into images, generate the images on that. Or it can do vice versa, like from image, it can tell you a story like what is happening in the image or what is the description of the image. So that like the AI has started reading the images, understanding the images, or trying to create the images from a story. So that has been happening in the case. Now, after that, like in 22, like Stable AI released a stable diffusion. Uh, so it was basically for high definition images that we have to work on. So if you like go to Google and see and mention the HD images, then only it will show the HD images. Otherwise, like it will show the low quality or low resolution images. So to create the HD images so that you can go into like more number of pixels are there and you can work or modify the pixels of the images. So that you can do using the stable diffusion. So that has been used in various art and like AI is generating art through it, and you can use it for content creation and content publicity. So that has been happening. So this came through. Then after this, Chat GPT 3 and 4 came. Basically, 4 I have already explained. Like it is a multimodal model, multimodal capabilities that is understanding video, images, text, and speech all together in a single go. And like, you can share everything to Chat GPT, and it will understand it and tell you about uh, the thing, how the text is connected to image, how the image is connected to video. So video and images are same only. Like video is a sequence of images, right? So if I talk about the image, it is a simple image. But if you put 10 images and run it in a sequence, then it will create a video. So yeah. it is able to understand the image, the model, then it can also understand videos by taking some parameters from it. Yeah. So the latest thing, the mid journey has been created. So it was creating abstract art from the description. So that has been in talk in when it was in. So till now, like we have covered like how AI is understanding text, and then we have like breakthroughs where it is able to understand the images. So how you can see like how generative AI is evolving through the time, and how like the thing we have today, it was basically it was a simple machine who was which was generating text sequences from there to till here, like generating the content by yourself, generating text, generating videos, generating images by themselves by reading the description, by understanding the human conversation. Basically. So coming to the next, like what are the future direction and ethical considerations? So as I said, like ChatGPT 4 is there and it is already understanding the videos and text images. So, like from your perspective, what else Gen AI can understand? Anyone want to give a try? So, like I think, like uh, even we are building smart homes, right? So when you integrate AI in smart homes, it is able to predict your next move also. Like when you are waking up, when you are sleeping, then it records that for a year and sees what is your pattern in 12 months in different seasons. So it can start predicting from Jan onwards your what you are going to do. How are your actions are getting predicted by reading the various sections for last month. So yeah, if this data can be stored, like if a video is stored where a person is living in his house for last 12 months or 24 months, so if you feed that into a AI model, then it can predict your next move. And how much close it is a different thing. But yeah, like everything can be done through AI. So like the more digital you are going, okay. So the data is getting stored into system like the digital meters, electricity meters are there. Uh, and like most of the digital payments we are doing on the phone, if all those things are getting recorded in the log, like if I monitor the logs of your mobile, like how many times you have opened your app or closed your app, how many times you have done the payment or something, then I can feed that into AI model and it can predict like what is your next move on your mobile. So if that is digital and your actions are getting recorded, so you are generating some data. So AI is need only data to predict or do something. So currently we have input, as I said, like text, image, videos input, and this thing. There are a lot of input in the world that can be recorded first and then can be fed into AI, basically. So yeah, that was like landscape of like currently I am talking only like how we are living. Okay, now consider its use case. I think that has been already happening in NASA or some uh, ISRO centers, like to predict uh, 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 to predict life on basically different planets. So they can monitor the planet for last 24 months and see like how, what is there, what is growing, what is not growing, and then can predict okay life for having life what is needed and what kind of environment is needed. So it is there or not. So maybe like not today, maybe after uh, uh, more couple of years more or after a decade we crack that okay some a life-like situation is there on another planet. So it's all like how we build the mathematics in the models and how we can uh, provide the input to the model so that it can work correctly. So all the things that has been done, like as I said, the history and foundation of Gen AI. So these things are already done. So these things are already available in the market. You just have to plug and play. Basically, Google provides that, Microsoft provides that, OpenAI is already building the community for ChatGPT. You can only download and try the ChatGPT and plug in your system and then predict, use it, whatever is known to us. So all these things are known to us. So whatever problem you have that in this domain, in text domain, video domain, so you can fix your problem using the Gen AI. But you cannot stop AI to this only. Like you have to elaborate more and go beyond. Basically, might be that is happening currently, and we are not aware of it. But yeah, that is a probability that can happen. So yeah, multimodal AI. So I have explained. So ethics and biases. So as I said, like AI is a knife only. Like either you put it for a good use or you can put it for a bad use. So either you can cut a vegetable or either you can cut a person through that. So it has bad usages also, like misuse of creating fake and creating fake news basically, and which would impact the economies or political decisions. So that has been happening. So uh, so that bias thing would be already there, always there. So how bias thing will come is like whenever you are feeding data into the model. Let's suppose you are feeding India's data for women or men, and like the average height of men is different than what is average height of men in US. So and you want to predict the average height of men. If you only give input of Indian men and predict the height of, and say like whatever output is given by model, we can take it for US, so that would be false. So it is biased towards Indian men only, right? So that's how biasing would come. So you have to create a different model for US and then work on. So yeah, that was the assistant biases. Then the rules, regulation and responsibility that is coming to us. So as we are hearing news in China and US, like uh, kids are banned using mobile, or kids are banned like 15 years, or elder kids are allowed on TikTok, not younger than that. So these news are coming. So it's our responsibility to put a regulation on that, and to see like how we can protect the data, and how we can put AI for good use basically, so that it will not uh, uh, hamper anyone's health or mental health, or like impact anyone in uh, any way. So yeah, that is it. And like the possibilities are endless. So whatever is known to us, like now kids are using ChatGPT for their homework. People are using for coding, and people are using for creating uh, business documents. So like it will evolve more, and day by day it will move in a good direction. So you can also like uh, see the use case. Now like the models were built and they were trained on whole data, right? Whole world data. Okay. But for particular businesses or particular problem to solve, we don't want our model to be trained on whole data, right? We want, okay, I am studying in AKG, so I will train this model on AKG data only and build our model. And that would be smaller than the chat GPT 2 or 3 that is trained on whole model. Okay. So that's the consideration you have to take, like while solving a business problem. You have to take only business data and train the model. And like there are various prompt engineering and different concepts are there where you can input the data while chatting with the chatbot, and they can build the model of solve the problem using your data. So that is it. So there are some Google resources. I will share you. Like there is a white paper by Google and video by Google experts basically. So they have taken through the LLMs and text generation journey. So before finishing, I want to take you through and done. Okay, so this is my screen is visible, right? I have this. Hello, Nitin, can you confirm?
Hello?
Yeah, my screen is visible.
Yeah, screen is visible.
Yes, sir, it's visible, sir.
Okay. Okay. So in Office, we are using QuickSight as a visualization tool. So I want to show you something. So here, like what AI is doing or something. So I've created one dashboard, one chart, and creating one line chart. So I'm taking the chart value. Okay, so here it is showing build. It is showing build. So I have created this chart using the drag and drop. So I'm clicking on build. So yeah, I have written this query basically before joining this. So I have written in the normal time, like future values of cart will be build. So if I click on build, yeah, it will automatically create that uh, visualization. Okay, and then this visualization here, I click add to animation. So it is created. So it saves it's like time saving than what I have created here. Like I have created and dragged and dropped this thing, and while chatting with them, it has already created the graph for me. Okay. So yeah, this is one of the use case. So if I go by so even if I don't know the technology here, the AI makes it easier to build it, right? So here you can see like it is giving brand wise starting. So you can see like how it is evolving. I first written the future values of this, then added the brand cut, then okay, it is showing the tabular, then I have added the inline chart. So even if I don't know this tool, I can use this uh, ChatGPT kind of thing and build this visualization. Okay, so that is what AI is doing. Like you don't have to know Python, you don't have to know R, but you can basically use ChatGPT, and it is integrated to every tool, and you can uh, build visualization, build stories, uh, build animations, build images out of it, and share it with anyone. So this use case I've seen like in companies, they don't want the ChatGPT to read their all data. They only want a specific problem to solve, and for that, like it is very useful. Yeah, that comes to the end of the session. Yeah. Anyone has any questions? No.
Okay, if anybody is having any question, just raise your hand.
Okay. Thank you so much, sir, for such a
Let me know if you have any questions.
Thank you so much, sir, for such an enlightening session. Your expertise has made this session incredibly engaging and insightful, leaving us with valuable knowledge and inspiration to explore further. Thank you so much, sir.
I think
Uh,
Abhijit has raised his hand.
Abhijit is having a wait. Abhijit.
Okay.
Okay, Abhijit, you can unmute yourself, open your camera, and ask your question. Hello, Abhijit.
Hello to everyone. Am I audible?
Yes.
Yes.
Hello to everyone. I have a very fundamental doubt regarding
Yeah,
RNN.
Abhijit and Shravan, will you please open your camera?
Okay.
Yeah, Abhijit. Yeah.
Yes, I have a very small fundamental doubt regarding RNN and CNN. So, how could you differentiate in which scenario RNN will be performing better than CNN or CNN will perform better than RNN? And on which behalf regarding on behalf of regression, classification, or on behalf of static data analysis or time series data analysis? So how could you know, or arbitrarily we have to opt, or is there any rules to follow? Because every transformer model uses RNN, and most of the AI models are also using CNN like that.
Yeah, thank you for your question. So basically, when I have used RNN and CNN, I have used RNN for black and white images for pre-processing, and when I have used CNN, it is only for colored images where you can use the RGB in. But yeah, like when to use CNN and when to use RNN. So CNNs are little faster than RNN. Okay. So if you read the implementation of CNN, uh, in CNN, basically there was some internal hidden state. They don't maintain that. So that's why that makes CNN faster than RNN. Okay. And like RNNs are more memory safe. Like in terms of performance, CNNs are faster, but like RNNs are like the hard disk or the storage RAM you need is lesser in RNNs, and like in CNNs, uh, like they can process the input of variable length. So like sometimes because the RAM needs to store the uh, while RAM to store the data while doing the CNN is so, like it depends on use case to use case, like when to use RNN and when to use CNN. So like if you are doing, and sometimes it is feasible that you use RNN and CNN both. So like you like while doing the image processing, where you are receiving a sequence of images, you can do CNN first and then convert the three dimension into single, and then use RNN later on to do a classification problem in that. So yeah, it depends on use case to use case. You can use combination of both, or uh, use either or RNN.
So, as per the basic knowledges we have, so basically images can be easily fed to CNN modules and things can be achieved. So, my question is, if I have a one-dimensional data, like any loss vector or anything else like that, so I want to use CNN onto that. So, what should be the approach? Whether we can have some one-dimensional features for CNN, or we can go for any kind of manipulations on that signal so that we can feed it to a CNN module and we'll get it.
Yeah, so like CNN would be beneficial because in terms of performance, it is faster. So if you say like one-dimensional images only and you have a huge set of images, and you have to process fast. So CNN would be better than RNN, no doubt. Like RNN is very rarely used in image processing. It is basically using NLP or text processing or something else. But yeah, CNN is very powerful for doing the image processing.
That means we can say that if you have a one-dimensional data, also you can 2D image, 2D image.
Yeah, right.
Like an image of suppose 100 cross 100, that will be 10 to the power 4 dimensional vector, and that can be also fed.
Yeah.
Okay, thank you.
Thank you so much.
Thank you. Have a great day to all.
Thank you, sir. Thank you, Rahul, sir. And in the last, we will share the tomorrow session link on the WhatsApp group, and attendance link only be shared in the chat box at the runtime only. And we will meet tomorrow for other interesting sessions. Thank you so much. Good night, all of you. Thank you so much.
Thank you, Millie, and thank you, everyone. Now you can leave the meeting.